So when we are talking about we are having some of the changes in the state of motion of the particular substance. Now what are these two things which are responsible? That is the change in the speed and the change in the direction. But now let us look at the other topic also, where the forces are applicable and they can change the other things also. That is, force can change the shape of an object. So earlier we have talked about the speed and the direction of the object. Now the next step that comes is about the shape of the substance also. How it can change. In the textbook we are given with some of the table and some of the examples are also mentioned. Let us look at them. So here you can see on the table there are some of the examples. The first one is a lump of the dough on a plate. So what we will do with it? Yes, we are going with our hands. So what will happen in that? Of course, the shape will be changed, but there will be no change in the speed or the direction, isn't it? Yes. So that will be resulting into the change in the shape. Then we have the spring fixed in the seat of the bicycle. Over there again what will happen? The speed of the seat will not change, the direction will also not change, but the change is in the shape of the spring. When someone will be sitting on it, the shape will be changed, but when someone is taken out from the seat, the shape again will be released and the spring will become again expanded. The next one is given as rubber band suspended from a hook. So nail fixed on the wall. So when a rubber band is just capped on the nail and then it is being stretched, the speed or the direction never will be changing, but the change is in the shape of the rubber band, isn't it? So that will be put as a tick mark over there. A plastic or metal scale placed between the two bricks. You can see in the picture also, in the table it is mentioned that what will happen over here? No speed change or no direction change, but it is a change in the shape of the scale that can be mentioned over here. So this is what we can have as the change as the result of the force. Now force of an object on an object may change its shape and it will be resulting in something else also. What are these points? Let us have a look at these points. Having performed all the above activities, you would have realized that a force can, what it can do. Let's have some points to be have in the light. May make an object move from rest. Yes. So can you remember about the example of the football? Yes. What happened? The football was at the rest, but when we kicked it, it started with the motion. So that was given by a force. The next one, may change the speed of an object if it is moving. Remember the example? The ball was moving towards us. We just applied a palm over there and the direction was changed. May change the direction of motion of an object. So here also again the same thing, where the speed also can change by putting the palm and the direction also can be changed by putting a scale or the palm in front of the moving substance, that is the ball. Okay. May bring an object up about a change in the shape of an object. We have seen just now a lot of examples, that is the door, the spring, the rubber band. These are the examples that we have seen which are having a result of the force to be changing in the shape. Then next one we have is may cause some or all of these effects. So sometimes it happens that all of these effects will be seen as a result of the force on a particular substance. Now let's go and have the other types of the forces. So which type of the other forces that we can apply to a substance? So here comes the first one, that is known as the contact force. Now what is this contact force? When we are applying a force to a substance, either it is in contact with the substance, isn't it? We have taken an example of the duster. Remember, when I pushed this duster, I am in contact with the duster. So I have touched the duster and I am in contact with the duster. So this force will be termed as the contact force. When we are applying the force within contact to the other substance, that will be termed as the contact force. Now you know that I am contacting the duster, but what I am doing from my body is I am applying a force to the muscles. I am making the energy in the muscles to move. So this is given another name also, that is known as the muscular force, because my muscles are working over here to move the duster from one place to the another. So the name given to the contact forces is the muscular force also. Without muscular force, you cannot move anything in the contact of the substance, isn't it? Yes. Now we have the another example, another thing also, that is known as the friction. Friction is really very important and very interesting topic. How it is important? Somehow you must have seen that your sole of the shoes, sole of the chappal or slippers have worn out. What is the reason for that? You don't go too much with the shoes also, but still they have worn out with the speed which you have taken out for running and for walking. But sometimes you get slipped, because what will happen? The designs or the patterns which are given for the grip for the shoes has vanished away. What is the reason to vanish away for that grip? So these are the reason, that is the friction which is responsible for moving out of the grip of your sole of the shoes or the slippers or the chappals. Yes, similarly we have the examples of the tires also. After few years, we need to change the tires of our vehicles. What is the reason for that? Again, friction is the reason for it, because friction will not allow the tires of the wheel to move with the same speed, because the grip has been vanished from the tires. So for when we are applying the brakes in the moving vehicles, that grip will not be again the same as it was in the new tires. So we need to change the tires on and often after few countable years, so that the friction is not again working in the same way. So let us understand what is this friction. As we say that friction is, for example, we have a car or a scooter also come to a rest once the engine is switched off. You must have seen when the slopey areas are there and you are driving through them, what will happen? You will just switch off the engine and you will know that the car or the bike or the cycle is going to move with its own speed, because it is a slopey area. But moving ahead, what will happen? After some distance, it will automatically slow down by its own speed. So this slope, it will be moving faster, but as soon as it will be reaching ahead, slowly its speed will be reduced automatically, and at one point it will come to a rest. So this will happen to the car or any of the vehicles when we are going or moving and switching off the engine. Sometime it will be coming to an end at a point. So what is responsible for that? Yes, friction is responsible for it. We have applied the force and we have stopped it also, and now the friction will be acting on this. So what will happen to it? There the speed gradually decreases and they can come to rest after some time. We have seen this example. Now, could some force be acting on them? We have applied a force and then we have stopped it. Yes, the force which is applied is the friction. Now, how does it work? Yes, the force responsible for changing the state of the motion of an object in all these examples is the force of the friction. Now, how it will work? The force of the friction between the surface of the ball or the car, that is over here the wheels, and the ground will bring a moving ball to the rest, moving ball or moving car to the rest. Now, how? Friction between the water and the boat brings it to the stop once we stop the rowing. When we are stopping the boat for rowing and we stay as it is, the boat will also come to a rest, because water and boat are having some force in between them that will be making them to stop at a point, means at a rest for that some time. The force of the friction always acts on the moving object. If I have kept my duster over here, do you think that the friction is acting on it? Not at all. But when I will start moving it, at the same moment the friction will start acting on the same duster. So what will happen over here? And its direction is always opposite to the direction of the motion. Now the best example we have is the duster itself. Now if I am making it at a rest position, there is no force also applicable, because it is now neutral gravity. So it is neutral force which is acting over here, means it is at the rest. But as I make it move a little bit by applying the force from my side, that is contact force, that is muscular force, or by pushing it. So what will happen? It will be applying a force over here. At the same time, the friction has started moving on it or applied on the same duster, and thus when I stop putting my force on the duster, this duster is going to stop, isn't it? So what will happen to it? The friction has not allowed the duster to move far. So the friction will be always acting on a moving substance and in the opposite direction of the force which we are applying to the substance. Got it now? Now we have another example, that is the non-contact force. Now we have studied just now about the contact forces. Now which are these? That is non-contact forces. Yes, the forces in which we don't need to touch the substance, but still we can apply the force to them, isn't it? Can you give me an example? This one is given in front of you. That is the magnetic force. Now what will happen in the magnetic force? You know very well that when we have kept two of the magnets in front of each other, and if the position of the one of the magnet is north pole on this side and south pole of the other magnet, what will happen to them? Opposite will be attracting each other, isn't it? Yes, but if I will put the opposite direction, means like this, that is the south and south together, what will happen? The like poles will be repelling each other. Without contacting them with each other, they are pushing and pulling each other. So this force will be known as non-contact force. We can have some of the examples how to do that. You can see. After this electrostatic force, let us see the gravitational force. What is this gravitational force? You of course know about the gravitational force because we have studied from 3rd standard also. So the force which attracts the substance which are going in the upper direction is known as the gravitational force. It is acting by the earth on the other substances. Not only on the earth, but all the whole of the universe, all the substances are just under this pressure, that is under this force, that is gravitational force, because in whole of the universe everything is acting because of this gravity only. We have the sun, we know the solar system, isn't it? Yes. What happens to the solar system? The sun is one who is having the gravitational force, because of which all the planets are revolving around it. We have the earth, because of the gravity the moon is revolving around it, and thus we have so many of the satellites also, artificial, natural, all of them are working because of the gravity also. So gravity is working in whole of the universe as it is. So let's study next one as the pressure. After the force, let's look at the pressure. Yes, pressure is very interesting topic. You also know during the exam times everybody under the pressure, isn't it? Yes. So that is what we have, the pressure. But during in the scientific reasons, what are the pressure actually? So let's have the look at it. We are given with a formula to find out how to measure the pressure of a substance. So pressure is equals to force given to the substance upon or dividing by area on which it acts. Now let me give you some small example regarding this. This is the first example, as you can see in the picture also. Yes, what is the person doing? He is hammering a pointed nail in the wood plank, isn't it? So what will happen? If you have tried this at your home, you would be knowing that if the nail is pointed enough, it will be immersed in the wood plank very easily by applying a little bit force. But if it is a blunt nail, can you just push it down? No, not at all, because a blunt nail will be having the spreading of the energy which is being applied on that nail. So if it is a nail which is pointed one, it can be immersed very easily in the wood plank. Now Paheli is having a query in her mind that now I come to know that why the potters, means the person who are carrying the luggage on their head, as you can see in the picture also, what they are doing? They are not taking the luggage directly to their head, but they are putting a rolling of the cloth on their head, and then they are taking the pressure of all the substances or the luggage on their head. Now what is the reason for that? Because the pressure which is applicable on this luggage will be now spread down because of the cloth which they have kept. Thus the pressure will be applied on their head will be less as compared to if they will kept as it is on their head. So it will be the pointed one. So for this reason the potters keep it in the expanded form. So the pressure applied to their head will be lesser down. So this is what the pressure we have. Now if in the solid substances we can have the pressure, can't we have the same in the gaseous and the liquid states also? Yes. So let's have a look at them also by doing some interesting activities. As we have seen that the pressure applied on a solid substance is always perpendicular to the substance when it is applied to the area. In a similar way, let's look at the pressure which is applicable to the liquid also. For that we need to consider and have the activities also. The first activity here we have is 11.8. As you can see in the picture, what is seen over here? Yes, 2 glass tubes we have taken, or we can take only 1 glass tube or a plastic pipe is enough. Then at the bottom, as it is a pipe, it is hollow from inside and it is ending with openings also. So, in one end we have to just apply a balloon and just have it in the proper manner to be fixed at the one end. Now we have to apply water in this pipe. What will happen if we have filled the half of the pipe? You can see here the balloon has just exposed itself, but a little, it has not bulged too much. But in the second case, when we have applied more of the water on it, what will happen? The pressure of the water is now increased and thus the balloon have now bulged a little bit more and the size has increased for the expansion of the balloon. Yes, this results in giving us that pressure exerted by the water at the bottom, as we can see over here, at the bottom of the container depends on the height of the particular column. So, if the height of the water is increased in the same pipe, what will happen? The pressure will also be increased on the balloon which is made up of the rubber. So, it has expanded a little bit more as compared to the earlier case, isn't it? Now, the next activity we have is activity 11.9. As you can see in the picture, it is given a bottle which is holded with a pipe at the bottom and having the again rubber balloon attached to the bottom side. Now, what will happen in this? This will be showing us that liquid exerts pressure on the walls of the container, because now we have attached the balloon on the wall side of this bottle, as you can see here. So, as we will increase the amount of the water in this bottle, what will happen? This water will be giving more of the pressure to the balloon to expand. And thus we can give as a result that this water is giving the pressure to the walls of the container also. Now, the next activity you will see in the practical manner. So, let us have this experiment. I have taken one of the empty plastic bottle. I have taken this big one needle which is going to help us to pierce the holes in the bottle. Okay. So, now we are going to pierce the hole in this bottle in such a way that all the holes are at same level to find out the pressure at the bottom of the bottle because of the fluid, that is liquid. Okay. So, let us find out that at equal distance we have to just pierce the holes over here through this needle. I am just going to warm it a little bit so that it is easy for us to pierce the hole. The last one. Okay, so 4 sides we have just pierced the hole over here, and in this next bottle we are going to have the holes in A, B and C levels at different levels, so that we can find out the pressure of the water. Two and the third one. Okay. Now, let us find out after filling up water in these bottles what will be the reaction. am placing a plate and now I am going to add water. We are going to have the holes to be fixed with the help of the sellotape so that water will not be coming out suddenly. I'm just wrapping the sellotape around the holes, around the bottle where we have kept the holes. Now let me add the water. You can see that the water has already started piercing out. Now you can see it's a bit like a fountain. At equal pressure, whole of the water has came out. Again, let's have a beautiful view of this. See, it's all equal pressure from all the sides. Okay, it just shows us that the fluid is exerting equal pressure at the bottom level. Okay, now let's try with the next bottle. Over here also we need to apply the sellotape. At level A, level B, and we have A, B and C. Okay. If you will be keeping it slant, you will be able to see it properly. Okay. Now let me add on water to it. It has already started coming out from here. Okay, so here we have level A, level B and level C. Now you people can just check it out that what is the difference between their level of flowing of water. Okay, so here is the least of the pressure, here is the medium type, and here we have the maximum of the pressure exerted by the fluid. As it goes down, the pressure will be also decreasing at the level where it is reached in the bottle. Okay, so this experiment shows that it also exerts the pressure at different level up to the bottom. As we have seen about the liquid, we can have the same pressure applicable by the gases also on their container. let's give you an example. The example is about the balloon. When you inflate a balloon, why do we need to close its mouth? Yes, because we know that the pressure of the gas will be coming out from its mouth because there is only one opening present. Because as it is applying the pressure to the whole of the balloon, we can say that because of the gaseous pressure on the rubber balloon, it has expanded, and when it is again flattened, what will happen? It will be released from the one of the opening of the balloon because it is giving lot of pressure to the atmosphere to release from the balloon, isn't it? So these are the things that we have seen, the pressure on the solid, liquid and the gaseous also. Now let's talk about the atmospheric pressure. What is this atmospheric pressure? Yes, even atmosphere also giving us a pressure. Yes, when we are standing in front of, when I am standing in front of you, the atmosphere is applying lot of pressure on me just now. It is on the head, it is on the shoulders. If I will expand my hand, now it is on my hands also. So, what is this atmospheric pressure? Yes, let us study about them. The pressure which is given by the gravity and by the atmosphere, means the air which is present on us, is known as the atmospheric pressure. Let me explain you by a small of the example. We know that the pressure exerted by the air is known as the atmospheric pressure. Now, if you will take a small of the hollow pipe-like structure being made from the chart paper and keep it on your head. Now, what will be the condition? If it is made from 15 centimeter by 15 centimeter, then you can cover this much of the portion of your head. Now, we can count the number of the pressure which is applicable on our head. It is mentioned that when the 15 by 15 centimeter of this column, when we consider that it is nearly equal to the force of the gravity on the object of the mass 225 kg, that is 2250 newtons applicable in this much of the area. Now you can think that how much we are pressurized by the nature, that is the air which is giving us the pressure. In the same way, if you are sleeping on a bed, more of the pressure will be applicable to you on all the body parts, isn't it? Yes. As we know that everywhere where we are going, air is present. So every portion where we are just exposed to the air, it will be giving us the pressure. Now, the small example we have is the suction. When we have seen the suction, as you can see over here in the picture also, what is this? Yes, this is applicable for the rubber sucker. We have seen that in the car windows also we have the rubber suckers which will be providing us with the shade so that the sunlight does not enter. But this rubber sucker is working how? Because of the pressure of the air only it is working. Yes, in the gap in between this rubber sucker, if the air is present, it could not stick to the particular substance. But if the air is moving out of its rubber sucker, then and then only it will be sticking. And because of the pressure given to this rubber sucker, it will be staying as it is for long on that area. Let me show you by the picture. The activity is something like this. This is the rubber sucker that we have. If we are going to apply this rubber sucker on the surface, what will happen? This is a straight surface, and if I am going to press it, what will happen? It will be just sticking to the surface. So this will be the sucker which is acting over here. Now as the air between these two surfaces have vanished out, this is sticking to the surface of the glass or whatever the surface is applicable. But here is also the pressure applicable which is having this sucker to attach to the surface. That is the atmospheric pressure which is working here and not letting the rubber sucker to taken out from the surface. So there we can utilize this atmospheric pressure in a purpose that we can use it. So these are the things which practically can be applicable. Now we are having, you must be having a question that so many of the pressures are applicable on our body just now, then why can't we burst out? If it is a pressure from the air also, from the top, then we should have been just become dwarf or maybe burst out. So what is the reason that we are not working like that? Yes, we have the internal pressure which is not letting the air pressure or atmospheric pressure on us to burst down. Understand? So here it is given that the reason we are not crushed under this force of the gravity is that the pressure inside our bodies is also equal to the atmospheric pressure and balances the pressure from outside. So what we are doing is something like this, that this is our body structure. This is a human body, and now when the air pressure is applicable on the body structure, from inside of our body also we are having a pressure which is neutralizing the atmospheric pressure. Otherwise what will happen, यहाँ पे हमारा pressure नहीं लगता अंदर से, तो क्या हो जाता अपने body की हालत, we would have just been crushed and we would have gone to the earth's surface, isn't it? As if you have seen about the balloon. अगर एक balloon को हम लेते हैं, उसके ऊपर हम इतना प्रेशर करते हैं तो क्या हो जाएगा, it will be bursting, isn't it? But if there is a internal pressure also from the balloon, then what will happen? There will be zero pressure applicable to this balloon, because here also some pressure is being applicable, means in our body also we are giving the pressure because we have the blood and which will be providing more of the pressure, means it will be neutralizing the atmospheric pressure and thus balancing the pressure for atmosphere. Now a nice example is given, that did you know portion is given to us in the textbook. Otto von Guericke, a German scientist of the 17th century, invented a pump to extract air out of the vessel. This was the first time which was being made. Okay, so in the 17th century they have tried, it is too early, isn't it? How their brain were working. See, with the help of this pump, he demonstrated that dramatically a force or a air pressure, he find out that air pressure, how it is acting. He joined two hollow metallic hemispheres, as it is shown in the picture also, you can see over here, 51 centimeter diameter, each of pumped air out of them. So it was the vacuum which was created in between this hollow ball that is made of the metal. Then he employed 8 horses on each hemisphere, as you can see in the picture it is visible, each hemisphere to pull them apart. One horse also gives a lot of pressure or the force by running, we know that. But here we have applied 8 horses on each of the hemisphere, means you can understand how powerful they would have ran. Now what happened? So great it was the force of the air pressure that the hemisphere could not be pulled apart. After giving lot of pressure also, they were not parted, means vacuum was acting so hard over there, means the air pressure which was acting on this hemisphere has acted such hard that the horses also could not do anything by applying the force to it. So by this way, here we finishes up with the atmospheric pressure topic and the chapter also. I hope you have understood all the aspects of this chapter. Thank you for viewing this.